An object is tossed vertically upward with an initial velocity of 3 meters per second at a height of 3 meters. How high did it go? How long did it take to get there? When does it hit the ground? And how fast is it going when it strikes? So we're going to look at this problem. An object is tossed vertically upward. So it has an initial velocity and it has a height of 3 meters. It's starting out already at a height of 3 meters. It has an initial velocity and it's being launched vertically upward. The initial velocity is equal to 3 meters per second. What's going to be the final velocity at the top of the path? 0. All right, so final velocity is going to be equal to 0 meters per second. I'm going to write the givens down here. Initial velocity is 3 meters per second. Final velocity is going to be 0 meters per second. Do we know how high up it's going to travel? No. Do we know gravity?
Yes.
9.81 meters per second squared. So we don't know how long it's going to take, and we don't know the distance that it's going to take to have to get to the point of the final velocity equaling 0. All right, so let's look at this. I always kind of look at the first equation. Vf is equal to Vi. It's going against gravity, so minus gt. We know final velocity. We know initial velocity. We know gravity. We don't know time, so we can use the first equation because there's one variable that we do not know. Vf minus Vi is equal to negative gt. And then divide both sides by negative g. Time will be equal to Vf minus Vi over negative g. Final velocity is 0 minus Vi is 3, and that's over negative 9.81. The negative signs cancel, and we're going to be left with a time of
0.305 if you want to round it, it's 0.306.
0.306 seconds. Good. All right. Now, we'll look for the distance. Distance is equal to VIT minus 1/2 GT squared. We just solved for the time, so we have that. We have gravity. We have initial velocity. We're looking for the distance, so we can use this equation. Distance is equal to initial velocity is 3. Time is 0.306 minus 1/2 times 9.81 times 0.306 squared. Again, be careful of the squared here. Make sure that the time is the only thing that you actually square in this equation. We're going to solve this in the calculators one step at a time. So 3 times 0.306 is 0.918 minus 0.5, 9.81, 0.306. That gives you 0.4593. And then 0.918 minus 0.4593 gives you 0.4587. I usually make sure the decimals have a 0 in front of them, and that's in meters. All right, now that's for the trip up. Now we know how much time it took to go upwards to reach a final velocity of 0. And we know the distance that it's going to travel upward is about 1/2 meter. And now we're solving for the trip down. So the object is now moving down. The initial velocity is the old final velocity, which is 0 meters per second. All right, the final velocity is equal to, we don't know. All right, so we don't know that one. Gravity is
9.81.
Okay. The distance that it's going to fall downward will be 3.4587 because it was launched with an initial height of 3 meters, and then it travels upward an initial distance of 0.4587. So that distance is 3.4587 meters. We know 3 things. We do not know time. Start with equation 1. Vf is equal to Vi plus GT because you're going with gravity now. We don't know VF and we don't know time, so we cannot use the first equation. Go to VF squared equals VI squared plus 2GD. We don't know VF. We do know VI. VI is equal to 0, so that whole term is gone. We know gravity. We know distance. So VF squared is equal to 2GD. VF is equal to the square root of 2GD. So 2 times 9.81 times the distance of 3.4587 and square root all of that.
8.24.
Okay, 8.24. Hold on 1 second. 2, 9.81, 3.4587, and square root that. Good, 8.24. All right, that gives us the final velocity, 8.24. And now we're looking for the time. We can go back to equation 1 because we now know final velocity. And time is going to be equal to VF minus VI over G. Final velocity is 8.24. Initial velocity is 0, 9.1. About 0.84 seconds.
Going to be negative. Oh, never mind.
Okay. All right. It's minus 0. No negative. If you ever end up with the negative time, you know you've done something wrong with the negative sign somewhere. So you have to figure that out. All right. Now, normally we figure out 2 things. One, the time, the total time for the whole trip. The time for the trip upward is 0.306. The time for the trip downward is 0.84. So 0.306 plus 0.84 gives us 1.146. That's fine. The distance that it traveled totally, the trip up was 0.4587. And the trip all the way down was 3.4587. And that equals
3.9174.
Okay, that's good. Roughly 3.92, 3.91, that's fine. Okay, that's number 3.